Tangents and normals. As previously seen, a tangent is a line that touches a curve at only one point. So a normal is a line that's at right angle with a tangent at that point. In the graph shown, the line making an angle of 90 to the tangent at point P is line ON. So we say that ON is the normal to the curve at point P. In example 8, we are going to find the equation of the tangent to the curve at the given point. We are going to use one important fact, that the gradient of the tangent at a given point is equal to the gradient of the curve at that point dy dx. That's a very important point we are going to apply in this section. So in part A, we have dy dx equaling to, that is 6x. Now since x is equal to 4 at that point, that will be 6 times 4 giving us 24. Therefore gradient of the tangent is equal to 24. So at x is equal to 4, we can as well find the y coordinate of that point by feeding 4 into the equation of the curve above. So that's 3 into 4 squared plus 2, giving us y as 50. So the point is 4, 50. We have the gradient and we have the point. Remember that this point is common to the curve, it's common to the tangent, and even to the normal. So if you take another point xy to lie on the tangent, so we have our point 450 and the general point xy. So that's x1, y1, x2, y2. So we use the formula y2 minus y1 over x2 minus x1 being equal to the gradient of the tangent, grad tangent. So that's y minus 50 over x minus 4 equals to 24. Multiplying through, that's y minus 50 will equal to, that's 24x minus 96. So that simplifies to y is equal to 24x minus, that is 46, is the equation of that tangent. In part B, we find dy dx as 9 minus 3x squared. So that is 9 minus 3 into x, which is negative 3 squared, giving us negative 18. So at that point where x is equal to negative 3, the y coordinate will be given by, we feed negative 3 into the curve, 9 into negative 3 minus negative 3 cubed, giving us 0. So the point is negative 3, 0. If another point xy lies on the tangent, so we have our points negative 3, 0, and the general point xy. So if we use our formula, y2 minus y1 over x2 minus x1 is equal to grad tangent. So we have y minus 0 over x minus negative 3 is equal to, grad tangent is negative 18. So we multiply through, that is y is equal to negative 18x, and that is minus 54, is the equation of the tangent. In part C, dy dx is equal to 6x minus 1. And that is 6 into 0 minus 1, giving us negative 1. So at that point where x is equal to 0, the y coordinate will be 3 into 0 minus 0 plus 1, giving us 1. So the point is 0, 1. So if another point xy lies on the tangent, the 0, 1, and xy, so our y2, which is y, minus y1, which is 1, over x2, as x minus x1 0 will give us negative 1. So that's y minus 1 is equal to negative x. And that simplifies to y is equal to negative x plus 1 as the equation of the tangent.